What type of cells are exist in case of ETAP or any kind of structure? Suppose the slab, flat slab. Suppose flat slab, and suppose the wrapped slab. Suppose the normal slabs we are discussing about. And now, to define this kind of slab structure, what type of element we should choose for designing in ETAB or STAAD Pro. Those are the finite element based softwares. Okay, so let us first discuss about the kind this kind of cells. There are two types of the cells exist. One is thick cell and other is thin cell. Okay, and thick cells are recommended when shear deformation are significant. That means where the shear deformation is predominant. Okay, and thick cells are also more accurate than thin cells. Even for thin plate bending problem, where suppose if we choose if we have to choose between the two kind of elements such as thick cells and thin cells, thick cells will define the bending moment problem more accurately. Here, the change of shear deformation or the change of the shear stress can be calculated more meticulously. Thick cells are sensitive to mesh distortion and large aspect ratio, so they should not be used for when shear deformation is known to be small. That means if we have to calculate large deformation of shear, then we have to choose the thick cells. In other cases, we can choose the thin cells one. And now, thick plate formation capture both shear and bending deformation. What type of structure? Uh, what type of structure define the thick cells? Thick cells. The wrapped slab, the foundation pads, and the transfer slab, column capitals in case of flat slab. These are the thick cells part. That means when we are modeling of this kind of structure, that means wrapped slab, foundation pads, transfer slab, column capital, and flat slab, then we can choose thick cells. What do you define or what do you differentiate between thick cells and thin cells? It is clearly mentioned a cell made of single isotropic material with a ratio of greater than 1 by 15th, 1 by 15th greater than a ratio greater than 1 by 15th. What is that mean? What is that mean? Let us discover about it. That means the T by D ratio is 1 by 10 or 1 by 15. They say isotropic material when the with the ratio of isotropic material considered as thick, and if the ratio is 1 by 15, the cell is considered as thin. That means T greater than D greater than 1 by 10. That means T is greater than D by 10. Okay. Now it is clear. If less than this is called, if this is the case, then we can, this is thick cells, thick. And if T less than D by 10, then T less than D by 10, then it is called thin cell. Okay. So this is clearly mentioned. And now another case is membrane. So it is said that it is in plane force only. It will, so basically, to describe the membrane, we have to know what are the in plane stress, and what are the out of plane stress. Okay. So now go to this picture. In plane behavior, the stress occurs due to the normal load acting through the plane of plate span is known as the in-plane shear. And out of plane behavior, the stress occurs due to the loading acting perpendicular to the direction of the plate is known as the out of plane behavior. Okay. Now, suppose this is a wall. And what is that mean in plane shear? In plane shear, that means this is the plane. This is the plane. This is the plane. That means that means this is the structure, and if any kind of force along this direction, this is called the in plane shear, and the moment is also same. If the moment is along the plane, this is called the in plane moment, and remainings are the out of plane. Okay. That means this is the out of plane and this is the in plane. So we can say it in case of STAD, we generally, this kind of coordinate system we generally follow. This is the x direction, that means in plane is x, perpendicular to the face of the wall is x, z, and parallel to the upward direction is called y. That means in plane case, in case of membrane, only this force and moment will exist. Only if suppose only this moment is exist, only this moment is exist. Clear? And now to define any kind of structure, there are two kinds of coordinate system we generally follow. This is the global axis and this is the local axis. Okay, the global means throughout the globe, that means the interface, the STAAD.Pro interface or ETAB interface, the whole structure will follow this kind of coordinate system, and each and every part, each and every unit of this structure, the orientation of the structure, that means suppose this is the block building unit of a structure, so that material has a particular orientation, and the material orientation is along x direction are different, y direction are different, and z direction is different, then it will call heterogeneous. Or and if both all the material distribution is all throughout all axis is same, then it is called isotropic. So we can change, there is also an option that we can change the orientation of this structure also, orientation of the structure, building units also, orientation of the building units also. So by this way we normalize the forces, the stresses developed in the structure, we can normalize it. So to define this kind of, so now we discuss about the membrane. The membrane is in plane force only, that means in case of membrane there is only one force, in plane shear and in plane moment, there is no other forces exist out of plane, that means moment or else anything else. So we, to prove that, we generally made three kind of different structure, and the materials are provided the same, the thickness of the slab is same, the thickness of the slab is same, but the type of elements, we generally, the type of elements, select how to select the element, how to select the element, sectional property. So select the element, how to select the element, the type, property data. So we can, by this way we can change the property data. Property data, that means it is a kind of slab, it is a kind of column, and the modeling type, how can we model the structure. How can we model the structure? So this is The all three structures have same element type, and the columns are also same. Columns are also same. Column 300 by 300 of M30 grade concrete. Okay, so we generally put only the loading, only the basic loading we have put. That means the dead load and live load ones, and the dead load and live load ones are not maintaining the live load, the particular IS code or any kind of code. We generally want to differentiate between three types of cells or membrane, whatever it is. So difference, how to the difference it, if we want to construct any kind of wrap slab or column capital. So to understand the structure, understand how to simplify the structure in this software. Suppose we want to construct any kind of model regarding the wrap slab or foundation pad, then we have to choose the thin cell. And if in case of normal RC beam structure, PT slab, flat slab, irregular slab, normal slabs are there are thin cell. Okay, so generally basic loadings are provided. You can check it, what are the loading applied. How can we see that? The cell load, if we see the cell load, we can check it. The 2 kilonewton 2 ton per meter square, which is dead load, and the live load is 2 ton per meter square. In both cases, this is also same, this is also the same. Now just run the software. Now let us unlock, because I have previously run it. So firstly, run the model. Now let us check the deformation. Let us check the deformation. The deformation along UZ, the deformation along UZ is maximum 0.016, 0.0616, 0.016, UZ 0.150, So the maximum is 0.150. This is, and for thick slab, for thin slab 0.153, and now look at this, there is no deformation happen in case of membrane. Okay, there is no deformation in case of happen in case of membrane. Only or everything is transferred to the supporting frame, that means beam and column. Very less. There is some deformation happens in case of in ends, that means these are the joints. So so we can check the stress display, the support reactions, we are checking Fx and Mx. Everything is transferred to the membrane, from membrane to the structure which supporting the slab. So the moment is more in case of moment and horizontal force Fx in case of membrane is more. Now let us look at the thin cell and thick cells. All are less than this. All are less than this. Okay. Now let us check about why. So everything is very similar. It is very much more than this. Very high value. The loads are equally same, so that's why upward reaction is same in all cases. Okay. Now let us look about the stresses. In plane moment, let us check. In plane moment, so suppose this is a structure, this is a structure, this is a structure. Okay. And there is a force applying on it. What kind of behavior we generally see? This is a fixed one. So always a fixed end moment. Okay. And for this part we assume it as a simply supported or fixed supported. We can assume this part as fixed. So this is centroidal, the force applying to at the midpoint. So the basic moment diagram is like that. And there is also a fixed end moment. we are discussing about only this span. So there is also a fixed end moment. So this is the fixed end moment. So fixed end moment. So how can we create another one? So for this case, if we this is the structure, the load is applied on it, the bending moment is this, and due to fixed end moment, this is the bending moment diagram. Okay, and due to the bending moment, there is a fixed end, there is also this kind of bending moment is exist. So basically this kind of structure, when there is a horizontal force here, but due to this force it will deform like this only, deform like this only, and deform like this only. So the bending moment is at the left part. So to a clear picture, to get a clear picture, the bending moment is very much like this. Okay, so now we check this data. Now we check this data, and what about the shear force? What about the shear force? Suppose this is the W. Okay, suppose this is the W, and this is the W by 2, W by 2. The shear force is distributed this way. Okay, and how, why this is coming, this portion is coming? It is clearly mentioned that this is the slab retaining structure. This is the slab retaining structure. Here 2 ton per meter square load is applied. So this is a UDL. Can you remember it? So when we discuss about the bending moment diagram or shear force diagram, so you have to be clear about the bending moment diagram. This is the structure, and load is transferred to it. The load is transferred to it. Okay, due to the UDL part, due to the UDL part, the bending moment is very much like this only. Okay. So now go to the structure. The everything is transferred to the, so the bend, the shear force is like that. And in case of thick or thin some amount of load is distributed to the slabs, so the shear force is less. So the shear force is less. Okay. Here you can check the value also. You can check the value also. This is very high in case of thin slab. Very much high. So this is the cell thin and this is the cell thick. Okay. Now look at the value. The cell thin 17, cell thick 18. This is the cell thick. The thickness is more. And in case of membrane, everything is transferred to the slab supporting structure. This is so the shear force is maximum. And suppose this is the moment. So it is clearly mentioned, if we want to draw any kind of, if we want to model any kind of structure where the horizontal slab does not carry any kind of load, so we generally choose membrane. And depending upon the thickness of the slab, we choose thick slab or thin slab. If it is wrapped slab or foundation pad or transferred slab, etc., then we choose thick cells. And if it is normal slabs such as normal RCB or slab structure, then we choose the thin one. Okay. So I have clearly mentioned the Fx and Fy. Let us check. This is the clear picture. The everything is transferred, the moment is high. This is the axial force.